All right, so we review our first derivative information. We get our critical numbers from where our derivative is equal to 0 or what? Undefined. Now, last class, we just said we get those critical numbers and we plug in those and the endpoints on the intervals. So for absolute extrema, a dead giveaway that you're doing that is that you're going to be given an interval every time. Relative extrema, we are not going to be given an interval every time. We're going to look at the whole graph, find all of the relative extrema. So what we're going to do is we're going to work with the increasing and decreasing intervals as well as the critical numbers to help us find those relative maxes and mins. So one thing we're going to need to know is that a function is increasing when the derivative is positive. In other words, f prime of x is greater than 0. Then, therefore, you can kind of assume the next one. A function is decreasing when the derivative is what? Yep, negative or less than 0. So f prime of x is less than 0. So what we were just saying then, relative extrema are going to be where f of x changes from increasing to decreasing. Let me maybe do arrows. Or decreasing to increasing, right? So that was our definition of that last year in pre-calc because we only ever looked at the original function. So we said, okay, let's use our calculator and solve for that relative max because it switched from increasing to decreasing. Or let's solve for that relative min where it switches from decreasing to increasing. Well, if we're defining the function being increasing and decreasing differently now, let's see what we will know then based off of our derivative. So if our function, let's follow with me for a second. If our function is increasing when the derivative is positive, and our function is decreasing where it is negative, where is that maximum going to happen according to the derivative? So if the original changes from increasing to decreasing, what's going to be happening on the derivative? It's going to be changing from positive to negative, right? So what we're going to see is our relative or our local maximum occurs when the derivative changes from positive to negative. Because positive is where our original is increasing, and negative is where our original is decreasing. So it's using that same definition, but it's using it with the derivative. So then...
Oh, because it goes up and then down.
Mm-hmm. So if you think about the original is going up and then coming down, and therefore we have a maximum there. But if we look at our derivative is positive, where it's increasing, and negative, where it's decreasing. So therefore, where our derivative changes from positive to negative, that's going to be where that maximum happens. So using the same idea, a minimum is going to happen where our derivative changes from what?
Negative to positive.
Yep. Negative to positive. All right, now just like we had some guidelines for finding the absolute extrema, we're going to have some guidelines for finding our relative ones. So we're going to start the same way we did last class. We're going to start with using f prime of x, our derivative, to find all of the critical numbers. We're still going to need critical numbers. And we know how to do that from last class, where our derivative equals 0 or undefined. Now, this is going to be different. So absolutes, we then check those critical numbers and the endpoints on the interval. You are not going to have an interval for this. We're just going to check critical numbers. So we're going to make a number line.
So does that mean you'll use all of the numbers?
Mm-hmm. It does mean that, yes. So we're not going to throw out any of our critical numbers this time. Yep, sometimes. So we are going to then make a number line to represent our f prime of x, our derivative. Based off the graph of f prime of x, we are going to label our intervals on the number line as positive or negative. Okay. This is actually where stuff really starts to come together. I don't know. I find this unit very interesting myself. Like it makes sense in my brain, and my goal is to help it make sense in yours so that you can put all the pieces together. Because the more it makes sense and you're not following rules, the better you get at it. Then we are going to label our f of x as increasing or decreasing and identify our relative extrema, which is our maxes and mins. Now notice, we're going to graph our derivative. We're never going to graph our original on this. We're going to graph our derivative and use its positives and negatives to tell us about what? The original.
So you always graph the derivative, but
We're-
you use the original?
Yes. So we graph the derivative, but it tells us about the original. The derivative is giving us information about the original.
Oh, but it tells us.
Yes. Now, we are not necessarily, the first one we'll start by graphing our f prime. We're going to hopefully get to the place where you can picture the derivative in your head, but it's going to take a little bit of review of polynomials. So we'll see that on the next page. Okay? So this is like our short version of our 3 steps. Find your critical numbers, do your number line for f prime of x and label it as positive or negative, and then we'll make conclusions about f of x being increasing and decreasing in relative extrema. So regardless, how do we get started on something like this? How do you find critical numbers? Derivative. All right. We can find a derivative. This was labeled y. We're going to call it y prime. What is going to be my derivative of this? X to the 4th minus 3x cubed plus 2x squared. Look how a very nasty original gave us very nice derivative. Now we look for where our derivative equals what? 0 or undefined. Is this going to equal undefined anywhere? No, that's fine. So let's just work for 0. So how do I solve? Where does that equal 0? We take out a greatest common factor. This is going to be take out an x squared. What are we going to be left with?
An x squared
Minus 3x plus 2. And then can we keep factoring?
Yes.
Yes, look how factoring never goes away. Okay, this becomes x minus 2, x minus 1. Now, it's also funny how this lines up with what I'm teaching in pre-calc. Because this is my derivative, and this is a polynomial. Do you remember polynomial zeros and end behavior? We did like the up, up, down, down, all of that, the chart. Quick review. We have the degree of our chart. Yeah, we reviewed this in the prerequisites, and it's coming back again, and the leading coefficient. The degree could be even or odd. Leading coefficient is positive or negative. If it's even positive, both ends go up. Even negative, both ends go down. Odd positive is down, up. Odd negative, up, down, right? So now, this is where we start drawing our number line. We don't want to draw a full graph of this. And in reality, we really don't want to have to graph it when we get better at this. But I'm going to show you the full thing for the first one, okay? So if I was to graph this, first, what's the degree of my f prime of x?
4.
It's 4. How do I know it's 4?
I could add that.
You can either add up the degrees in your factored version, or you can go back to the original and say the highest degree is x to the 4th, okay? So that's an even degree. What kind of leading coefficient? Positive. So which way are both ends going to go? Up, okay? So when I draw this, we're going to do this purely on a number line, and we are not going to draw a full graph. One of those weird notation things, not weird, it'll make sense in a minute or in a couple days. We're going to both be graphing the second derivative on a number line and the first. So you need to say which one this is. We are graphing right now y prime. So you need to label that. Where is my graph here going to have x-intercepts? Okay, at 0, 1, and 2. It does not matter if this is to scale, like at all, because we're not even going to graph it. Eventually, we're going to get to the place, in fact, probably on the next one, where we don't draw a graph on this at all, and we just label positives and negatives. So if I had to graph this, we said both ends go up. What happens at 0? Do you remember that? The bounce, right? So I know if I was to graph my derivative, it's this end is up, bounce, cross, cross, both ends go up, yes? Like I said, I'm doing that this time, but I want you to be able to picture that in your head. Now we label our number line as positive or negative based off of whether our derivative is above the y-axis or below. So like this section right here, up to 1 or 0. Is this positive or negative? It's positive. It's not whether it's increasing or decreasing. Is it above the y-axis? That's it. Positive y values.
Is it x-axis?
X-axis, yes. Then this section, positive or negative? Positive. This section, negative. This section, positive.
So do you do it where it's like,
You don't have to do it like above or below. I just did it because of where it was.
no, I'm saying like, how did you, like every time it's the x-axis, then you have to say.
Yes.
Okay.
So this section up to 0 is all positive. 0 to 1, all positive.
And then it's
1 to
x-axis.
2 hits the x-axis, goes under. Yep.
Okay.
Does that make sense?
Makes sense.
So based off of this, I have not looked at my original at all, right? This information on the derivative tells me about the original. So on the previous page, we said the original function, f of x, or y in this case, is increasing where my derivative is what? Go look at the previous page. We filled in the blanks and we said our original function is increasing where our derivative is positive. So remember how we used to write increasing, decreasing intervals last year? We can do that without ever looking at the graph of the original because of the derivative. So we now know y is increasing. What intervals would you say it's increasing?
0, negative, infinity.
So all the way back, because what does this arrow mean? Goes all the way to negative infinity, all the way. Do I have to like split it here?
No.
No, because it stays positive.
So
So
negative.
it's increasing all the way up to where?
1.
1. So I say y is increasing from negative infinity to 1. Where else is it increasing? 2 to infinity. Yes?
And it's only parentheses on
Yes. Then I would say y is, it doesn't matter.
You don't care.
You can use it, you don't have to use it. I was taught to use it and I've dropped it because she says it 100% does not matter for AP. So,
Okay, then.
drop it. Y is then decreasing in which interval? 1 to 2. Now, before I move on, look, here's where people get confused. They will look at this and say, but this is not increasing here. This is the derivative. We're not saying where the derivative is increasing. We're saying where the original is increasing. So this graph is not going to tell me, like this is not going to necessarily match up with where it's increasing because I'm not talking about this graph. I'm talking about this one that we have never looked at.
So if
Right?
we were to graph the original,
Yes.
we would look at the other and think, oh yeah.
Yes. If you graph that original, which we can do in our calculators in just a second, just to see, this original would be increasing up to 1 and then from 2 out. Okay? Now you can also tell where it has a relative max and min based off of this. So again, referring to the previous page, we said we have a relative max where our derivative does what? Changes from positive to negative. So look at your number line. At which x value does your derivative change from positive to negative? 1, right? It goes from positive to negative. Yes? So that tells me our original y has a relative max at x equals 1. Now what I want you to get in the habit of is saying why, so that you know. Remember how when we talked about horizontal tangent lines, it was always you got to say f prime of x equals 0, f prime of x equals 0. Same kind of thing here. It has a relative max at x equals 1 because y prime changes from positive to negative. Knowing why is a huge part of this, being able to explain why you know that. Because there's going to be things the second derivative tells us that maybe you could have used that piece of information. So in like a free response, you got to tell them you know why. What are you looking at? What tells you that? So then I would also say y has a relative minimum. Where's that going to happen? At x equals 2 because why? Y prime, the derivative, changes from what? Negative to positive. Okay? Now, just for the sake of argument, you guys don't have to pull your calculators out, but we're going to look at the graph of the original just to see. Okay? See how it matches up.
When you really
All right, so you could leave it here and see where it's equal to 0 by thinking to yourself, where is cosine squared going to be equal to sine squared? That's probably the harder way to think about it unless you're very good about the chart. 2, one of these is a cosine of 2x formula. So that whole thing can change to cosine of 2x and see where that equals 0.
Wouldn't that be easier because you can just do that?
Yes, I find that to probably be the easiest way. If you didn't think about that, what's one other way you could think about it?
No, it's not a big.
Oh, don't go there. No, you don't want to do that. But you could actually, yeah, because that would ask me where is cosine equal to sine or where is cosine equal to negative sine. That's similar to the first way. The last way I was thinking was either substituting for cosine squared or sine squared and putting it all in terms of 1. I would have probably substituted for cosine squared and made it 1 minus sine squared for that, and then minus another sine squared. And then this is just solving a trig formula. So that would be 1 minus 2 sine squared is equal to 0. So you subtract the 1, divide by the 2, and square root. Any preference to which way we go?
Let's try like cosine.
Okay. I think, yeah, this this is fastest.
And I
Yeah.
think that was the most important.
This is the fastest way, 100%. So this one is the one where we say to ourselves, where is cosine equal to 0? Pi over 2 and 3 pi over 2, right?
Yes.
Typically on these kind of questions for calculus, when we did these in class, we like extended out and found more answers.
Right.
Most of these you do not need to do that with because they've got a pretty short interval on. So if I do that, but remember, these are not my answers for x, these are my answers for what? 2x. And then we take all of our answers and do what?
Divide by 2.
Divide by 2. So what do I get?
Pi over 4.
Pi over 4 and 3 pi over 4. Those both fall within the interval 0 to pi.
Yeah, that's so the way to go.
Mm-hmm. So the only caution I would say is if they fall like too far within it, you might have to find more answers. Remember how we added 2 pi to the original? So we could have said if it's pi over 2, it's also 5 pi over 2. If it's 3 pi over 2, it's also 7 pi over 2. Neither of those would fall within the interval, but it's something to check if you need to. So like here, we didn't have to. There, eh. Okay, so those are our critical numbers. Now where do we go from here? This is the new stuff.
Number line.
Number line. Okay, number line, and what is this number line?
For f prime.
F prime of x. Get yourself in the habit. On there, we then label it as pi over 4 and 3 pi over 4, because those are our critical numbers.
Right.
Yes?
Wait, do we not use the 0 here?
We don't use
Is that not?
That's not a critical number.
It's just saying,
This gave you an interval purely because trig keeps going. So if I didn't give you somewhere to look at, it's like you could say pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, like keep going, all of the
You don't use
answers.
that on your-
We don't need that, nope.
Wait, why don't we use them though?
Because of this interval right here, it's cutting us off 0 to pi. So if I had had these answers and divided them by 2, I would get these.
Yes.
But those are larger than pi.
Right.
So we don't use them just because they gave us the interval 0 to pi.
But on the other one, we like plugged them in too, right?
Right. We did. Anything that was in the interval, though.
Okay, so we.
This is out of the interval, so
applied the interval to the derivative.
yes. So even on the other ones, we did not plug those in because they were outside of the interval.
I mean, we plugged in like the interval.
Yes. But here we're not plugging in anything.
Oh,
So we're not going to we don't use 0 and pi.
okay.
0 and pi is purely for you to just know where to stop with your sign answers. Okay? All right, now, quick question for us. What are we graphing here?
Oh wait, we got the derivative. F prime.
We're graphing f prime. I personally don't really know what that looks like. So this is another argument for going to this. I'm much more able to graph that. Now, that's not a parent function we know. We're just going to have to think about it, okay? All right, so we know, here's what we know. Okay, so we know those are zeros, right? I just need to know whether it's positive before it, and after 3 pi over 4. All right, so let's just think about it. What comes before pi over 4? Something easy. 0, right? 0 comes before pi over 4. If I think about what is the cosine of 0 there? What is the cosine at 0? 1. So is that section going to be positive or negative? Positive, without graphing.
Wait, how did you know?
I said, okay, a number over here is 0, right?
Yeah.
I plug in 0 to that right there. If I plug in 0 there, 2 times 0 just becomes 0, right? What is the cosine at 0? 1. And because it's a positive number, that whole section's positive. Okay? Now, if I was smart about this, I would remember cosine waves go positive, negative, positive, right? So do I really need to plug in any other numbers? No, because I know what a cosine wave does. And I know this is going to be negative here, and this is going to be positive. If you're uncomfortable, plug in a number in between. Like in between pi over 4 and 3 pi over 4 is pi over 2. If I plug that in, I'm going to get a negative number back out. But I'd rather you be smart about it and remember cosine goes in waves. It saves so much time.
So if I plugged in cosine of pi,
Mm-hmm.
it would be pi.
Because when you plug in pi, it becomes 2 pi in there, and cosine at 2 pi is back to positive 1. Yep. But, again, I'd prefer you to remember the parent functions because it makes life easier. Okay, so now we can make our conclusion statements here, right? Our conclusion statements will be where we are increasing and decreasing and where we have relative maxes and mins. Okay, so what are we talking about now when we write these? The original or the derivative? Original. F of x is increasing on what interval? Negative. Okay, now so here's again where we bring in that interval. We're only looking on the interval 0 to pi, right? So we're going to start at 0 and go up to pi over 4. I can't say negative infinity to negative pi over 4, can I? Because it just keeps going back and forth, right? So that's where we're going to just say they started our interval at 0. We're just going to start our increasing at 0. Then it's also going to be increasing 3 pi over 4 to where our interval ends, which is what? Pi. Trig ones are a little tricky this way because you have to kind of just look at a snapshot of it. Then, okay, and also I should have said this on the last one. There is a reason for this. How do we know it's increasing there? Because why? Our derivative is greater than 0 on those sections. Question?
If you chose a point, so we chose 0 there.
If you went too far, you would have gotten something wrong.
Okay.
You know what I mean? Like you have to go within that interval still. Yep.
Wait, why did you say, because the last one we said.
We should have said it. The increasing. I should have said because y prime is greater than 0.
Oh, we're not writing our statements yet. Okay.
Oh, we are on the bottom here. Yep.
No, I was saying.
Oh, the relative maxes and
we said
mins?
From positive to negative, but this one.
Yeah, we're not there yet. We're getting there.
Okay.
Yep.
I got it.
So there's like 4 statements for this.
Last one we should have said.
Set a reason. Yep. Then I can say f of x is decreasing. Where?
Actually, I got an 84. Okay.
Decreasing where?
Pi over 4 to 3 pi over 4.
Pi over 4 to 3 pi over 4. Because why?
Your derivative.
Derivative is negative or less than 0. Then I make my statements about relative maxes and mins. I say f of x has a relative max where? X equals pi over 4 because why? F prime of x. I know. See what I mean about the notation? You're making statements about the original, but your reasoning is because of the derivative. So it's tricky to remember which.
A relative max of what?
Well, we don't know what the relative maximum value is.
Oh, okay.
Oh, wait.
Now, could I find what the relative maximum is?
I don't know.
I could. How would you find what the relative maximum value is at pi over 4?
We plug it in.
Plug it into where?
The original.
Original. So the original is sine x cosine x. So sine of pi over 4 and cosine of pi over 4 are both root 2 over 2. So it give me 2 over 4, or 1/2.
Wait, Miss Hunter, I'm
Mhm.
confused on what.
Okay.
I'm not able to find.
So, you know when we did absolute maxes and mins, we said you have it at the x value and the maximum value is the y value?
Yes.
So like on the last one, we didn't even list what it was because it was kind of ugly. But this one, let's go ahead and find that, okay? I'll erase this for a minute. We have a relative max at x equals pi over 4 of the y value. How could you find the y value at pi over 4?
Plug that x value into the
Go back to the original and say, what is f of pi over 4? That's sine at pi over 4 times cosine at pi over 4. So root 2 over 2, root 2 over 2. If I multiply those, what am I going to get? 1/2.
This 2 times 2 is 4.
Because f prime of x changes from positive to negative. We'll do the same with the min. Might as well find it. It depends on the question, whether they will just say find the x value at which the relative maximum and minimum happen, or whether they'll say find the points at which. If it's the points, you got to plug in the x to find the y.
So this one we technically didn't have to.
No, but I just wanted to show you that you could.
Okay.
It just depends on the wording, honestly.
So this wording, we don't go.
This one is actually sketchy as to what it means. It says just identify the relative extrema. It doesn't say whether that's x's, y's, or both. I will be very clear in my wording. I will say find the x value at which, or find the points at which. If it says points, then you need the x and the y. Okay?
And then
I might pick out a couple on your homework and just tell you, find the full points on those. Okay? So then we're going to say f. We have a relative min at x equals 3 pi over 4 of, how will we find our minimum value?
Oh, you do the angle, like the.
You can, but you just have to plug it back in.
Oh, okay.
So you can go back to the beginning and say, okay, f of, I ran myself out of room here, 3 pi over 4. What's the sine at 3 pi over 4? Sine at 3 pi over 4 is root 2 over 2. What's the cosine at, it's a negative root 2 over 2. So what's the minimum value then here?
Negative 1/2.
-1/2. Because what's our reasoning?
F prime of x changes from negative.
F prime of x changes from negative to positive.
So the relative max, you use your.
All right, so once we have our x's, we got our x's by solving, right? Now, how are we going to get our pluses and minuses here?
Can you just look at the.
Yeah, just look at your calculator graph. We don't have to figure it out on this one. It is what to the left of your first one? Plus, after it? Minus, plus minus. All right, do you think you can write your statements here about these? Okay, now this one, we're not going to find our y values for this because this would be ugly to plug it back in, yeah? And you don't have the original, so could you even plug it in? No, you couldn't. Yep, so don't worry about that. So see if you can write your 4 statements based off of the ones that we've talked about. And I'll write mine slowly and then we can check. All right, so there's the rest of that. There's all of my statements there. Make sure you're good on those statements. And I know it may not say write out these statements in your homework. If it was me, I would do it. You should just get in good practice of that, okay?